This is Isi M.Math 2017 solution. So let's see. So let f of r to r is given by a function. So we need to prove that it is monotone. So this is again a real analysis based question. So on the basis of the observation, fx equal to h of g of x if we take. So what gx equal to e to the power xs cube plus x, that is this part, and h of y equal to y to 1 plus y e to the power r square dr. So we have, let's do the first order derivative. So g dash x e to the power x cube plus x 3x square plus 1 greater than 0. So h dash x equal to e to the power 1 plus y whole square e to the power y square. So e to the power y square taken common, e to the power 1 plus 2y minus 1. So in particular, what is happening? H dash y is greater than 0 for y greater than minus half. So since gx is positive, so we have h dash of gx greater than 0. So that will give you g dash x positive. So obviously f dash x equal to g h dash g of x g dash x greater than 0. Hence strictly increasing. Hence it's a monotone. So monotonically increasing, so first part is done. Next, question 6. This is about a matrix space. So let W equal to W of ij be a m into n systematic matrix with non-negative real entry such that W of ij equal to 0 if and only if I equal to j. So show that D of ij equal to minimum of this and this matrix space. Okay, so in this case, so first we verify the verify that the minimum is achieved. So consider the path. If we take I1, I2 dot 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 ik between I and j of the length k plus 1 greater than equal to m plus 1. So among the elements I0, I1 dot 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 ik, so there are at least two identical elements IR equal to IS, so for R less than S. Then I0, I1, IR minus 1, IS dot 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 IK, this whole thing is a path of length less than k plus 1. So W of IR minus 1, IR equal to W of IR minus 1, IS. Okay. So now what we can do is, we can do it like summation to 0 to k minus 1 if we took IL plus 1 greater than equal to summation of L equal to 0 R minus 2 W of IL plus 1 plus R minus 1 IS plus summation of W IL comma IL plus 1. So this is again S equal to k minus 1. So it means that enough to consider that only the paths less than m, so paths less than equal to m. So there are only finitely many such paths, so it's finite. Hence the maximum of the definition D of ij if we take is achieved. And now we check the axiom of the matrix. So for any path I0, I1 dot 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 ik minus 1 ik equal to j between I and j. So we have this IL plus 1. So this is also positive. So hence Dij Okay, so dij, this thing is positive, so assume that dij is equal to 0. So since the minimum of the definition is required, so dij is achieved, so we have this summation of w of il plus 1 equal to 0. So this is the first part. And for some path of the ia, so we also have il plus 1 equal to 0, where l equal to 0 dot 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 k minus 1. So now if we follow from the definition, then I0 equal to I1 dot 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 I k minus 1 equal to Ik. So in particular what we have this thing, and that is equal to j. This equality will get you to equal to j. So we now have proved that d of ij greater than equal to 0 and d of ij equal to 0. So ultimately I equal to j. So now if we consider the other path, that is I0 equal to I and I1 equal to I, then this d of I of y will give you this value. But d of I is actually greater than equal to 0, so d of I is equal to 0. So this proves that d of ij equal to 0, so which proves I equal to j. Now if we consider another path, I0 equal to I1 dot 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 Ik minus 1, Ik equal to j, then d of ij is summation of w il plus 1. So we can observe that if we just reverse it, ji summation of l equal to 0 to k minus 1 l plus 1 comma il. So this is nothing but d of ij itself. So we prove that d of ji is less than or equal to d of ij. Both the values are so. Since this is true for ij, we can also say it for the other values. Okay. So this is also true in a reverse way. Now if we take the path I0 equal to I1, I2, Ik, then j, then R of 0 equal to j, then R1, R2, Rs equal to R. So if these things are there, so d of ij summation of w il plus 1 d of jr, so this is equal to summation of w rp r of p plus 1. So observe that this I0, I1, this thing equal to Ik, and R0 and R1, R2, R is a path of I and this is a path of R. So d of I are here is less than equal to W summation Ij comma Ij plus 1 W Ik R1, that is summation equal to P equal to 1 S minus 1 RP plus 1. So we can use J of R1 okay, so Ij plus 1 J to R. So this triangle inequality is proved. So D is a metric on M. So hence the answer.